Okay, this is a sweet little topic where you basically have to tell a story. Okay, this thing measures just how far you've gone on some sort of journey. So this is the distance, this is the time. So let's say that's 5 kilometers. That's 1 hour. Yeah, so what's the story?
Well, they went for a really fast run, and they chilled for a bit, then they ran a little bit, and then they went backwards. And then
I didn't go backwards.
Yeah.
Oh, no, wait on.
You do.
Oh, okay, I'm terribly sorry. This can't be measuring how far you've gone. It has to be measuring where you are relative to a point. Or else you wouldn't be able to have your time going down. Does that make sense?
Okay, so they went.
Sometimes the graph looks like that. Sometimes it looks like this.
But they went backwards.
Yeah, right. They must have gone back to where they started.
Yeah.
Yeah? Unlike that. That's just how far you've travelled. Even if you're going backwards, you're still adding to the distance you've covered. Whereas this is your distance from the starting point. Now when you get into year 12, we have to be very disciplined about which of these we ask you. We even have different language for how we refer to these key terms. But for GCSE it doesn't matter. Okay, just use common sense. So they went out hard, had a rest, came back. Which was faster? The outbound or the inbound? The outbound because that's steeper. The inbound because it's not quite as steep. Okay? So flat equals rest. Steep. Steeper equals faster. If they ask you for an actual speed, what do?
Gradients.
Just use the gradient. We do a distance time triangle from physics. Okay? So what's the speed for that guy? 5 kilometers in
Is it like 20?
20 minutes? So it's 0.25 kilometers per minute. Okay, you can use whatever units you want for that. Lydia?
The first graph, it seems a bit weird because it's like they're unrunning the 5k that they've just run. Do you know what I mean?
No,
like
it
should
should
be
be
them
a
adding
circle.
If this is measuring your distance from your starting point,
Ran all the way back.
this is the logical graph.
You're not going to run all the way
out
out
and
and
then
then
came back ran and then you went back, and that's
Like
what
say you were running from your house and you ran all the way to
That's
Tesco's
5k,
and then you ran all the way back.
It's
to
like
your
you
house.
ran in a circle.
So, okay.
Yeah?
It just seems like you'd be like unrunning it. Do you know what I mean? Like,
You cool?
If they're running,
I totally dig what you're saying.
they're running 10k, aren't they?
5k out, 5k back.
Yeah, so they're running 10k.
Yeah, now this rest, if you go for a walk around your place where you're resting, you can even stop that climbing by always making sure you're the same distance from where you started. Like if this is where you started and this is the park where you have a rest, as long as you just move like that, if this is where you started and this is some park where you're having a rest, if you always go like that, that graph will not climb because you're always the same distance from the starting point. This graph, however, if you even have the slightest little walk around the park where you're having a rest, that will climb a bit. Yeah? The fact that it's resting is just the fact that it's not as steep. Okay? So that's the real life graphs for distance. Okay?